right, good afternoon. So hopefully you are all now fed and caffeinated. I think a few people are still trickling in from the poster session, but we're going to go ahead and get started. So this afternoon we're going to have a great panel discussion about investing in energy innovation with voices from industry, government, and startups. And before I introduce our moderator, I just want to mention how we're going to do questions. We're going to be, a couple officers are going to be walking up and down the aisles with index cards and pens, and we're going to, if you have a question, just kind of like get one of our attention, and we will pass you an index card and pen, and then like raise it up when you're done, and we'll collect it from you. And then that way we can just streamline the questions a little bit more if they're written out, and kind of group them by category. So yeah, and now I will introduce our moderator, Ted Weaver. He's the president of First Tracks Consulting Service. He works with utilities and government to deploy large-scale sustainable energy programs, and he also has a great background for this panel. He's previously worked at a municipal utility, a state agency, and an energy service company. And he's also the Boulder Regional Chair for the Clean Tech Open Accelerator. Leave it to you.
Okay, thank you, Kristen. Well, welcome. We're thrilled to be here as part of the Energy Frontiers Conference. So what we're going to do is I'm going to introduce the panelists, and actually I'm just going to say their names and give them a chance to tell you about them and their background. We'll start off with that. Then we'll have a discussion that goes on for half an hour or so, a little more. But I do encourage you to have questions. We'll save time at the end for questions. So do write some down and get them to Kristen or the other officers walking back and forth, and we'll have some back and forth at the end. If we don't get any questions from you, you're going to have to listen to me more. So it'll be more fun for all of us if you guys contribute. So I want to welcome to my left here Barbara ONeill. She's the manager of Transmission and Grid Integration Group at NREL, at the Renewable Energy Laboratory. Robert Schutzius is the Reservoir Engineering Manager at Anadarko. John Obrecht is R&D Engineer in Blade Design for Siemens Energy's Wind Power Group. Joe Parker is the founder and CEO of PCM International. You're all going to hear about what PCM means, but I'll save that for Joe. And then Trevor Sermon is on the end, and he is the co-founder and managing partner of Farmore Capital Group. So I'd like to start off if we could just go down the row, and again, each of you introduce yourselves and tell the panel a little bit more about yourself and your background.
Hi there. So again, this is Barbara ONeill, and I work for the National Renewable Energy Laboratory. Hopefully you all had a chance to listen to the first panel where Eric Payne spoke for our Technology Transfer Office. And earlier, if you saw the keynote, Dan Arvizo, our director of the lab, actually spoke this morning, which was a wonderful presentation. So I've only been at NREL for a year and a half. My background, I am an electrical engineer and then have a grad degree in management. And I work for the Power Systems Engineering Center there, which is a part of the Energy Systems Integration business unit. And as part of the ESI, we have this new lab called the ESIF, the Energy Systems Integration Facility that you might have heard of. It was just sort of brought into operation about less than 2 years ago, and to much fanfare. It was a big feather in the cap of NREL because it's sort of DOE budget line item expense, and it's gorgeous, and it has incredibly cutting-edge facilities for testing lots of new technologies. But forgive me if I can't answer much from the whole history of NREL, as I've only been there a year and a half. Before that, I was working for a developer doing solar and wind utility scale renewable projects. And then before that, I was with Xcel Energy in Denver.
Well, good afternoon. My name is Robert Schutzius. I am a reserves manager for Anadarko Petroleum in Denver. My educational background is that I hold a Bachelor of Science in Civil Engineering degree from a prestigious research university called the University of Colorado at Boulder. And then I also hold an MBA from the University of Michigan at Ann Arbor. I began my career in June of 1981. I had been recruited right here off campus by Shell Oil Company and began with them in California. Worked for them about 7 years. Then I did my MBA full-time for a couple of years. And upon graduating, I joined ARCO, Atlantic Richfield, at the time was a Los Angeles-based oil and gas company. Was with them for about 10 years until British Petroleum bought out Arco. And then I exited the industry in the state of Alaska, where I was at the time. Moved back home to Colorado, this time to northern Colorado. Worked in high tech for a while, worked in the healthcare industry, and ultimately found my way back to the oil and gas industry with a small exploration startup initially, and then Anadarko for the past 4.5 years. So thank you for the invitation to be here. It's an honor to be a member of this prestigious panel.
Great, thanks. So I'm John Obrecht. I'm a research and development engineer. I work for Siemens Wind Power. I did my PhD work here at the University of Colorado in physics, and I moved away from Boulder. I hated it, and I had to find a way back, and so I got a job with Siemens as an engineer, and who knew, but I really like wind energy, and I was well suited for the position that I hold. Siemens' office here is in Boulder. We do blade design for wind turbines, and the office was largely started to support the turbine that we have at the National Wind Technology Center between here and Golden, and that was about 6 years ago. And so our office is about 30 engineers. We do blade design. It's like aerodynamics, loads, controls, and structures. And we also do test and validation out at the wind turbine. So it's nice that we're so closely located to a turbine where we get to go touch the turbine, try different things out. We do noise measurements up there, loads validation, controls validations. And so that's a little bit about us. And what I do recently is less blade design than it used to be, and it's more like technology development. So I think that's why I was asked to come be on the panel. So thank you.
Hi, I'm Joe Parker. I'll tell you what phase change material is. PCM stands for phase change material. We make a lightweight form of thermal mass that goes into building products primarily. That's been our focus, although we're getting ready to start work on a product for packaging this coming week. My background is not engineering. I've never taken a physics course. I took one course in calculus, and I don't even know where it was. So I'm the non-engineer in the group, unless Trevor, he's an engineer too. So I have an MBA in finance from University of Virginia, Darden, and so that gives you an idea of how I ended up in this. I've been interested for the last probably 15 years in using waste products and building materials, and we got a call from somebody in the UK saying, can you put phase change material in a wallboard? And I'd come across that, in 1991 in Raleigh, North Carolina, where I was living, and said, yeah, I know something about phase change material, non-engineering wise. So. And that's how we ended up working in phase change material. And like a lot of startups, you stay nimble, you adapt to what comes through the door, and we are now going through one other iteration of developing our own form of the raw material, phase change material. We were buying an encapsulated phase change material from BASF, but we are now going to be able to produce our own in scalable volumes to what our market is. So I think we've been a Clean Tech Open finalist and looking at some of this. We are extremely small compared to the rest of the folks at the table. Just say that. What? Is that maybe?
Yeah, except for maybe us.
Yeah.
So Trevor Sermon started Farmore Capital Group, which is an early stage investment fund. Then also started recently Stakeholder Ventures, which is a venture fund. They're both focused on a lot of the same areas. So if you go back to my junior year in high school, and this won't be as long and painful as it sounds, but my dad's an engineer and a serial entrepreneur. I said, all right, Dad, I want to start companies, so I'm going to go major in business. And being an engineer, he said, for God's sake, if you want to start companies, don't major in business, major in engineering. And so I said, all right, well, if I'm going to do something with a T model, so I'm going to go a mile wide and inch deep in engineering and science, and then deep in kind of business management startups. And so kind of made up my own undergraduate curriculum, broad in engineering and science. And then ended up going to the Naval Research Lab and working on high performance batteries for the military for a while. Started off in the PhD program, material science and engineering. Doing biomedical implants, still broadening the top of that T. Switched to environmental engineering with a nuclear focus, so I did plutonium work in grad school. And then it got done. I said, okay, I want to go work at a startup company. I said, you know, you did nuclear work. You have to go to a national lab again. So I went and did a few-year stint at Oak Ridge National Lab, and then finally got recruited to a startup company called Curion. And Curion was the only U.S. company to get a prime contract with TEPCO. We did radioactive wastewater treatment at Fukushima, kept the water from getting into the ocean. So I led kind of the engineering side of technology development for them. Curion kind of got big. I left and spent a little bit of time as an EIR at a friend's firm, and was doing some angel investing with a good friend of mine, and so we started Farmore Capital Group. So Farmore Capital Group is just the two of us. We don't have limited partners. We do a lot of clean tech, biotech, med tech, mostly in the Bay Area. I live in Boulder, but I spend a tremendous amount of time in Palo Alto, and most of our portfolio companies are there. And that's led to, there's a few investors I really enjoyed working with, and some people that liked our portfolios, our personal portfolios, and so we're starting Stakeholder Ventures, which is a small, early stage venture fund focused on kind of energy, water, ag tech, an AI/robotics/IoT focus area, and then mobility and transportation.
Thank you. So we've got a great mix, and Jake and his team at the Energy Club have put together a great mix of people. We've got Barbara from a national lab doing more pure research, the early end of the innovation cycle, if you will. And then, Joe's working for a startup, a small company that's moving new ideas from new ideas to real companies. Trevor investing in companies like Joe's and others. And then two large established companies, Anadarko and Siemens, large companies that have been around a long time. And actually, and that's kind of that's one way of looking at the innovation cycle. So in this first round, I kind of want to go in that order. And just, this is a panel on innovation, so each of you are really at different stages of companies or organizations. So just, if you could talk a little bit about what does innovation mean at your organization? What's an idea look like that's coming in the front end, and what are you doing with it to move the ball down the field? And just a little bit, that's a big topic, so just a little bit about how that works, and we'll come back and loop back through. But let's start with Barbara, and how do you do it at NREL? And I realize Barbara's not representing all of NREL that's doing wind and solar and oil and gas research, just within the T&D group.
And we're not really doing oil and gas research exactly, some biofuels. And people think of NREL in terms of, very innovative, which it is, and, cutting edge R&D, and there are widgets that do come out of NREL, but I feel like it's not, things that are in silos and in isolation. I mean, for NREL, a lot of it is to take something that exists and to make it just a little bit more efficient or a little bit better, or change the material underneath it. And so we have these commercial partnerships that really try to foster this kind of, just take it one step further. And we can put money in, Department of Energy can put money in, and for us, pushing that technology forward into an ultimately deployable form or commercially successful form is the win. But it's not always just a physical thing. For me and my group in the transmission side of integration, a lot of that has to do with changing, for example, operational practices out in the power industry. So we go to an RTO, for example, and explain to them how if they change their requirements for operational reserves to accommodate inverter-based technologies or variable generation technologies, how that could help the higher penetration levels of renewables that we foresee in the future. So innovation doesn't have to be a physical widget. It doesn't have to be something that stands alone. It can be incremental, and it can be a system thing. In other words, the R&D that is done out of my group, in a lot of cases, is done via computer models and doesn't have to do with working in a physical lab. We do have, as our Siemens rep, John mentioned, we do have utility scale wind turbines and 1.5 megawatt PV array and storage pads at our National Wind Technology Center right off 93 here, where we can put into practice the things that we're doing research on, and that's really helpful. But in the end, if you're going to move it forward to a whole grid, in other words, the Western Interconnect or ERCOT market, that kind of thing, then you have to rely on some other players to really get that into the marketplace, as it were.
Let's jump down to Joe. So Joe's kind of the next step. And you've got one technology. I realize you're not working with a whole portfolio of technology. But talk about where did your phase change material idea come from, and what are you doing to move it along, and what's a win look like for Joe?
Well, I would say that we started with a need or an application that came out of something I was involved in. So it came from a process of linking an in-market need with some technology that came across through one way or another. It could have been through a friend, it could have been a group that I was working with. In this particular case with phase change material, I was living in Raleigh, North Carolina, and lived there for quite a while, and was working with basically reviewing business plans for presentations to a group with the Research Triangle area venture groups, like Rocky Ventures Club there. And they asked me to review a plan that was an application of phase change material. So the first time I ever came across phase change material was under that. And then, years later, I get a call from, we were working with a process to enclose, enrobe, utilized waste material in building products. And I got a call from the UK through a connection saying, have you ever done anything with phase change material? Well, I just did happen to have some limited experience in that. And they sent us some material. They had an end product in mind, specific end product in mind. And my concern at that point is the same it's always been when I look at something like this, and that is, it's one thing to have an application that will work, but it's another thing to get it into the existing implementation stream. You can't change the way people are building buildings. You know, you can't change the distribution system. You can't change how people are measuring some of this stuff. So you've got to think about how a product is being manufactured, and we just backed up from there. Tell you the truth, that's the innovation process we went with, and we started with micro-encapsulated little teeny bubbles of wax made, and they're great, but they don't mix too well with other products in creating a composite, and they burn nicely. So they're not very adaptable to building applications. So we developed a process that made it easier to blend it into composites and made it fire resistant. And that's the connection we made, and we backed up from there because we knew that you couldn't take these little micro bubbles and sprinkle them like pixie dust in a building. You got to have a carrier, you got to have a method to get it in there. And so from a development standpoint, that's been our focus, and we backed up from there. And I wake up in the morning and I then remind myself how I got to where I am at this moment. Some days you don't know.
Yeah, let's jump to Trevor. So now Trevor's looking out at ideas and companies that are getting into the market. So, you know, what comes in your front end of the funnel, and how do you move it forward?
How do I vet it? What do I look for?
Yeah.
So at a high level, one of my, everybody's heard of disruptive innovation, right? So my working definition of disruptive innovation is a 10x improvement in a key to the customer performance metric and or half the cost. So when I'm sitting down over coffee or a beer with an entrepreneur, that's kind of the high level thing that's running around in the back of my head. And then there's a lot of other things like, can this team, do they have the domain expertise required? Can they execute on this? But, at a high level, when I talk about an innovation that's interesting to me as an early stage investor, it's got to hit one or both of those criteria.
And then do you feel like your company or your organization is moving the ball down the field? Are there things you're doing that move innovation along, or do you find the innovation and just do something with it?
Well, so I don't really get too involved in most of the companies. I sit on the board of, right now I'm only on the board of one, a few advisory boards. So I'm not too involved in the day-to-day operations trying to move the ball down the field that way. Most of my value comes from my network. I know a lot of people, and I can meet with the entrepreneur, the CEO of the company, and help connect them with people who can help them move the ball down the field. In terms of, I think part of that question was kind of where are we getting opportunities from? I think that's part of it. Part of that is, the key to being an early stage investor is to have access to the absolute best deal flow, right? The top 1% of companies produce the vast majority of the returns. And so, most early stage investors think they have access to the best deals. most of them don't. And so a lot of what I do, and I think a lot of what has been key to our success, is having access to the best stuff coming out of Stanford and Berkeley and MIT and CU and things like that. And so, I spend a lot of my time those places, and we've invested in a number of companies, with alumni from those schools or associated with them. And so that's kind of just continues to build that network, and that's, how we get new deals, and that network is how I provide value for our portfolio companies a lot of times.
All right, let's jump back to Robert. And Robert, I know you're in a piece of a big company, but maybe, within your division and within Anadarko more broadly, how does your company think about innovation?
Well, I'd answer it in a couple of ways. We are in a commodity business, and what we try to achieve is getting the most hydrocarbon fluids out of an underground hydrocarbon reservoir for the lowest capital invested and the lowest operating cost. At the same time, being safe operators, respecting and adhering to all state, federal, and local regulations, and being wise environmental stewards as well. So an example, I work at the Wattenberg field, and if you drive I-25 between Denver and Fort Collins, you're driving over an active oil and gas field, and occasionally you do see drilling rigs and et cetera there. That field began being developed while I was in junior high school, 1970, and it's been under vertical development for 45 years. Our scientists have determined that we think that we've recovered maybe 10 to 12% of the original oil in place in that reservoir. And with the horizontal program that's currently underway, they think that they can boost the recoveries into the 15, 16, 17% range, which means that you're leaving 80 to 85% of the hydrocarbons in the reservoir. So the name of the game for innovation at our company is really to get more resource out of the ground. And research is conducted in a couple of different places. Internally, we have a technology group that will look at things like seismic to try and understand what the structure of the reservoir looks like underneath. They'll analyze fluids from the reservoir. They will also analyze pressure data. Again, sometimes it's laboratory that they're doing these things out, or sometimes it's spreadsheeting. And we also do kind of applied research in the field, tinkering with things like wellbore design, wellbore spacing, number of stages, the completion designs and things like that, trying to optimize the design out of the reservoir to get the performance that we're looking for. And separately, the oil and gas industry, even from the time that I joined 34 years ago, is an extremely outsourced industry. So a lot of the research and development that is going on in the oil and gas industry is done either by drilling contractors, or done by completion contractors, or done by health, environmental, and safety contractors as well.
And John, same question.
Yeah, so addressing innovation at Siemens. So hopefully you guys know who Siemens is. It's a worldwide company. We have 500,000 people worldwide. The engineering department at Siemens Wind Power is like 3,000, so we're a big company. When it comes to innovation and technology, it's not our main driver. Like, we want technology in our products, but it's not what fuels us. It's more infrastructure. So when we talk about technology, it's got to be product focused. And so where we come from is we sell products. And so if we get technology into those products, that's how this works. We want things that are low risk. We want things that are simple, robust. And so as a big company, we don't take those giant risks that maybe national laboratories and universities can. That's kind of where we rely on them. So it's in terms of Siemens, like I said, it's very product focused, and we're always told in our department, we don't sell technologies, we sell products. And so, I don't know, 6 years ago when I started with Siemens, I was that bright-eyed kid that came in and just everything was a new technology. Oh, we should be doing this, we should be doing that. And now you have to look more on the economical side of what's commercializable. That's something that we look at very closely. So.
Interesting. So we started with Barbara really talking about technology and monitoring and systems, and more the technology end. But as we went down, certainly Trevor's looking at the money. Joe brought in more of the markets. Trevor is an investor, and then we ran with John talking about it. It can't just be moving the technology forward. It's really got to be driven by what is this company trying to do. So back to John and Robert again. In bigger companies, how much so how do you come up with ideas and decide where we're going to spend our time on the innovation process? Are they being generated internally, and do you have some process for screening ideas, or are they coming in from outside? And just either one of you jump in. And
Products.
How do you think about that?
So it comes from spreadsheets and meetings. It's priority lists and taking good ideas, putting them on paper, evaluating them, and it's I don't know. It's trying to take a stepped approach to getting things into a product. So it's pretty rare for us to take something that hasn't been proven in a national laboratory or proven in academic papers or journals. It's pretty rare for us to come up with something just on the fly. So we're constantly looking at, we go to conferences looking for those new things. What's on the market? What are other companies doing? A lot of businesses are just copying what other people do and do it better. So it's not, here we're at an innovation, meeting, but that's probably from what our side, what we do.
And I would say probably similar. We do a lot of quote-unquote experimentation as we're developing an oil and gas field, trying different completion techniques, different wellbore designs, stimulation volumes, things like that, just trying to see what works. And if you can find the recipe that works for you, then you could do it in mass. You reproduce it as if it were kind of like an assembly line, if you will. But the other thing too is because outside vendors have expertise in things that we internally don't have, we oftentimes listen to their recommendations for solving our problems and apply those and see if those work any better for the problems that we're trying to solve. So.
Okay. All right, let's start a new topic. Really, a big theme of this whole conference is how government and industry works together. And so I'll probably jump right away from Barbara because you are government. But for the other guys, and just jump in, how are you leveraging the investment that that in the government labs and how the labs or how the government is funding university research? And that's where some of the new ideas are coming from. So, how are you leveraging that? And anyone can jump in. I don't. Yeah.
Well, it's very difficult for a company like ours, very difficult, because of the structural dynamics of both the national labs and the universities. If you look at if some of you heard the talk this morning, you missed it if you didn't, but I have worked with, attempted to work with Oak Ridge and NREL. And they really are not set up to be a part of your development team, which is what I needed. I mean, we don't have certain high-tech testing gear. We can't do electron microscope pictures of our composite to see what the distributions of the particles are in the material, and we don't have the equipment to test. And they are not set up to have somebody of our size come in and say, we'd like to get an SEM reading of this material. So that's one thing. And then not CU, I may say, but another institution in the state I went to one time to go after a grant with them and Oak Ridge, and basically I'm a numbers guy. I'm used to walking in. If you ask somebody for money, you tell them what you're going to do with it, right? And this professor just said, well, just put me down for $150,000 in the grant. And that kind of went over my head. And the researcher at Oak Ridge said, oh, you can get all that information from industry data in the modeling, and which I wanted him to participate in. I really just was not able to get in the door with that. And it's not a criticism, don't get me wrong, of what I'm saying. It's not a criticism of them. It's structurally we need to make some changes if we want to get companies our size working with government on innovative material that's not the next new solar panel or the next grand design. There are a lot of very interesting innovations in the clean tech area that are, we need all of that technology. I liken it to a cafeteria. I worked for Holiday Inns in my early days, so You know, I mean, but you go down a cafeteria line, you know, you've got a selection of things, and when you go to solve an energy problem in a building, you have a collection of alternatives, and not all of them are, you know, the next big solar panel. There are a lot of little innovations. We have filed some IP on putting a sensor in our material, which would help us get efficiency out of it. Well, we were dealing with a ceiling tile company, and they said, well, we're just not interested in that, you know. So getting those kind of niche innovations early is really tough.
So you've had trouble leveraging the government programs, it sounds like.
I haven't been able to leverage the
Anyone
government.
else that's had more success or other troubles with what the government programs are currently doing?
Yeah, I mean, I can speak to it from, you know, one of our portfolio companies' perspective where they've had success. It's probably most helpful. So one of our portfolio companies is a company called Motive Power Systems. And so Jim, the founder, and this is also kind of an example of, you know, clean tech 1.0 versus kind of clean tech 2.0 or 3.0, whatever we're on now. So, you know, companies like Proterra, not knocking Proterra, but went out and raised hundreds of millions of dollars to build NewCo Model 1 all-electric bus. And the companies say, you know what, we've got a bus we like. We don't want your bus. We just want our bus to be electric. And so Jim is working on his PhD in electrical engineering at Stanford, and he said, you know what, electric motors are commodity products. Battery packs are commodity products. Depending on what part of the country or world you're in, you want different battery chemistry anyway. So let's just build an operating system that allows us to talk together, and then when the garbage truck or the school bus comes down the assembly line, you put an off-the-shelf electric motor, off-the-shelf battery pack, and you've got an electric vehicle. And so he dropped out of the PhD program, took a fair amount of the department with him, and immediately raised $6 million in non-dilutive capital from the California Energy Commission. And then, you know, we invested right after that. He had tens of millions of dollars in orders. We invested in the first equity round, and, you know, very capital efficient. And, you know, the California Energy Commission, in this case, government, allowed him to dramatically de-risk that and get to, and start generating considerable revenue.
Right. For the bigger companies, again, have you been able to leverage any of the government programs, or
yeah,
are
so
there
we've
things
done a
that-
couple things with government funding, and from my perspective, what I see is that government funding can help us to lower risks, help us to do projects that we normally wouldn't have done without that funding. I think it's pretty obvious, but it's more like we've had opportunities here at the National Wind Technology Center doing projects where we normally wouldn't have done these projects because they just were outside of scope and just a little bit too risky. So in terms of what we were able to do is we had a government funding project for 3 years and able to do projects that we absolutely wouldn't have done without that money. So those are things that eventually we will put into our products and commercialize. Obviously you have to make some of that public and what we did because it was government funded, but that's kind of what we've taken advantage of in the past.
And that's Department of Energy funding? Is that
Yeah,
where
that was
came
Department
from?
of Energy
So
funding.
federal money.
Yeah,
Right.
and in addition, like I said, we have this turbine here, the wind center, that came directly from a government funding. So it's a 5-year program, CREDA program that we were taking advantage of there. In addition to that, I see other things as, looking at the tools, the research that can be done by government that's just, like I said, a little bit outside of our comfort zone in terms of risk. We don't want to go down a road and do 5 years of research on a topic because we could have been spending that money elsewhere or time elsewhere. We want things to have a rapid return rate and not something that's going to take a long time to develop, whereas a national lab can do something like that. And so that's where a lot of that money can be well spent.
I would first of all say that I think, we in conventional, well, we're not conventional, but oil and gas industry, we're in a different phase of the life cycle than most of the other industries represented here. So we don't rely a whole lot on government research to do the jobs that we do. But if you were to go back in time to the late 1940s, it was actually federal funding too, and I don't know if it was Mitchell Energy or Amoco Energy. They put some money behind hydraulic fracturing and doing field testing on perfecting that technique. And that subsequently was used in unconventional reservoirs for probably 60 years after that, and it's now being applied in a horizontal environment. So my industry has benefited by government funding for exploration and production research.
So let me turn it around and ask Barbara. Again, I laid out this very simple innovation cycle where the labs create an idea, and then a little startup, takes it and moves it up the curve a little bit, and then that either gets bought out or turns into a large company. But my sense is it's not that simple. So, and you guys, so as you're developing new ideas and new models, what kinds of companies are you working for, and how do you get things, transferred over, as you talked about?
So I think I should back up and just discuss the myriad of ways that government works with private industry. So, and let me even tell you that NREL is not actually a federal lab. I don't work for the government. I actually work for a private organization that has a contract with the federal government to run the lab. So it's a 5-year contract that typically gets renewed. But my computer and my cell phone are owned by the federal government, but my paycheck comes from a private company. So 95% of our funding, of our about $380 million of revenue, comes from federal money, but about $20 million comes from commercial, from industry. So we have a lot of these public-private partnerships, and John mentioned CRADA. That's a cooperative research and development agreement. It's one form of agreement. Now, the federal government does programs where they require cost share. So they'll put out a solicitation and say, okay, we're going to give you NREL or another lab or any other federally funded R&D institution money, as long as you can match some of that money from commercial industry, because they want other money to come in and that to actually get pushed out into the commercial marketplace. So that's an example where you need to collaborate with industry. You can also collaborate, and it's encouraged to collaborate with universities. Universities provide not only a great source of ideas and innovative R&D topics, but they also honestly provide cheap labor. I mean, I've got my full-time staff, and then I've got my postdocs, I've got interns, and then I've got students that I can utilize through university collaborations, and that provides even bigger bang for the buck. So there's lots of different ways. Now, the federal government, they initiated the ARA program, right? The American Recovery and Reinvestment Act, which provided for loan guarantees. And Solyndra fiasco notwithstanding, those loan guarantees are a really great vehicle to kind of backstop the risk, to de-risk that profile of a new technology. But it is true that some of these programs require a certain threshold amount of money. So if you're a small company with an idea and you don't have a whole lot of seed money, and you're trying to get in with somebody like NREL or some big institution, there is a transactional cost that's high enough that sometimes it's hard to make that relationship work well. But ARPA-E is a great example of of a program that's looking for those disruptive technologies and really looking to spend a lot of money on getting those potentially huge disruptive technologies to market.
So we're starting to get questions from the audience, so that's great. I'm gonna read one because it's on point here, and we'll spend some more time at the end. But again, questions are welcome. So anyone else who has them, find Kristen or the other officers and write them down. I've been talking about innovation and maybe have teed it up this way for you guys about really it's more a technology push. So here's a good idea, and how do we push it out into the market? The question here is really about consumer pull. So how do you guys think about that in your organizations, and rather than pushing something out onto the market, finding out what the market is looking for and bringing something to that? Maybe start with Trevor.
Yeah, no, that's a fantastic question, and one that has been kind of knocking around in my head listening to people talk about this. So all this scar tissue over here is from technology push, right? I think that, there's this whole debate in venture capital about, is it all about the team or is it all about the market? And I think it's a combination of the two, but huge market pull is, I think, probably, if not one of the biggest determiners of success, right? And that's one of the things we look for. So I get really skeptical and really nervous when it's, hey, we've got this great technology and we're looking for a pain point to solve. I want to see, hey, we've got this massive pain point and we found a solution for it. It doesn't seem like that big of a deal, but in terms of success and magnitude and probability of success, it seems like a really huge deal.
Any others, Siemens or Anadarko? How do you think about consumer pull and how you're investing your innovation dollars and what eventually makes it through the funnel?
Yeah, in terms of new products, maybe wind power is a little strange because it's an emerging kind
Right.
of technology right now. Things are getting bigger every year. When I started, the biggest rotors that we sold were like, I think 100 meters, and now they're getting up to like 180 meters on the market. It's crazy. It's doubled the size of the turbine. So it's always new products. What do we have? How can we beat our competitors? Because there's always going to be somebody putting out something better. So we're always listening to that, and it's every 3 years you have to be releasing a new product, like a major new product. So we do listen to the customer side, the customer value. And in addition, we also do like service things. We also have to maintain turbines and take care of them. So in terms of innovation, we do have a close connection to customers, but mostly from the market side, what products have to be on the market to stay fresh and stay competitive.
And Robert, you're in a commodity market.
Yeah.
So I'm not even sure what customer pull means for you.
Yeah, I'm not sure if I know either, but
Yeah.
our direct customers would be oil and gas refiners, and then would be also natural gas processing plants.
Right.
So that's where the immediate next step in the chain is. But ultimately, it comes down to the U.S. or worldwide markets, the markets for crude oil and natural gas. Combined, those two products provide between 60-65% of our primary energy needs. Crude oil being what is refined into gasoline, jet fuels, things like that. Natural gas, which is the second largest source of electric power generation fuel, also used for home heating and a lot of industrial purposes. I guess the way I'd respond is that you tend to see a constantly increasing demand in the marketplace for the products that we make and produce. So our struggle is to provide those to provide those products, get them produced, and again, recognizing that they are commodities that can swing wildly in price, as it has in the past 6 months. We say in the business, you plan for the worst and hope for the best, and that's certainly true of our industry.
So I've heard a number of references to risk and de-risking, so that's great. I wanted to get at that. And so far, I think it's been, free money is de-risking. That's good. So if you can get a pile of cash, then what you have in the game is it's easier to move it along. Are there other kinds of things you guys are doing? I mean, innovation by its nature is risky. Some of these ideas are not going to pan out. So how are you thinking about risk and how you develop a portfolio of ideas and move them along? Maybe I'll start with Trevor, because you should be the guy that understands risk the best at the table.
I think I have an unreasonably high risk tolerance. Is probably what I mean. Yeah. So I mean, obviously, risk is huge. I mean, in venture, the kind of prevailing wisdom is you invest in 10 companies, one hits it big and returns the fund, right? Most of them are going to fail. We haven't had any failures yet. It's pretty good. I mean, they're all growing. Between my partners and I, we've invested in, excluding funds and accelerators and things like that, north of 30 companies, and they're all cruising right along, so that's good. One of the things that we do, and we're going to do a lot with this new venture fund, is have corporate partners. So partner with Siemens, for example, and maybe work to de-risk the technology de-risk our portfolio by working with them, understanding what their needs are, and finding, companies that address some of those needs, right? That's one way to do it. The other is, all right, now we've got this company in our portfolio that's strategic or interesting to you. Let's do a proof of concept pilot or something so that you can really work with that portfolio company. You all can walk together, and that will help to de-risk the opportunity.
Any others? I mean, working on a portfolio of ideas. Again, how do you balance that portfolio and have more winners or just how do you think about this?
I can touch on the topic. It isn't really relevant to the sector of the industry that I work in, which is development. But in the exploration side, you basically manage risk by engaging other partners. It's very, very common in the oil and gas industry where an offshore Gulf of Mexico well might cost $20 million, and you don't know if there will ever be a payout for it, is that you parcel it out and you bring in other operator or other companies. You might be the one that's operating and actually doing the drilling, but other people actually fund their working interest share. So you do that for the same reason that Trevor pointed out before. You're going to hit a lot of failures, and it's only the 1 out of every 10 or 20 that comes in, and it needs to come in big to pay out your overall exploration program. But that syndication is essentially what we do in the industry to kind of manage our exploration risk.
John?
So speaking on behalf of Siemens, maybe I'll take a step back and say that Siemens has been around for 175 years or something. So in terms of risk, I don't know, maybe it started out risky, but now as a big company, it's probably not as risky. And so it's a slow-moving vehicle that has the infrastructure to put things onto the market at a large scale. So in terms of risk, I kind of agree with Trevor that what we try and do is test and validation. Is if we're going to try and do something new, we have to kind of prove it and in a staged approach too. It's not just go throw out a new product that has some wildly new technology that isn't proven. We really have to take a staged approach. So it's always demonstrating step by step that we have something worth putting on the market, something that's just money in the bank. I think that's kind of our perspective.
Yeah.
Just as a follow-up and as a little plug for NREL, I mean, just like Siemens has one of their turbines up at our test site, it makes sense for companies to leverage the dollars that taxpayers have paid in, basically, for the equipment and facilities that national labs have, because that's the proving ground. And if somebody's already created the capital investment for infrastructure for testing, let's get into partnership and do a proof of concept there. That makes sense. And then the other piece of it is that we are unbiased. We're not like a consulting firm that kind of has an angle and trying to get new business or trying to schmooze their way into some other marketing opportunity. We are here to not be advocates for any particular policy, even NREL. We're not advocating for renewables. We're just providing fact-based research. So it's a good partner to have in a collaboration, because generally the research that comes out is respected as fact-based.
Okay, we've been talking a lot about process and getting generic abstract ideas and moving them down the field. Let's get more to results and more concrete. And so this is a panel on innovation. I'd like each of you to just tell the audience about some wildly innovative product, idea, business that your organization's been working with, or if you can't talk about that or you don't have any, just an idea that you've heard about recently that you think would be interesting to the crowd.
Cool.
Yeah, John, jump in.
I could start. So I think the best example of something like that would be on the wind turbine side is the aeroelastic tailored blade technology. If you're in the wind power industry, you may know what this is the fact that as wind turbine blades get larger, they tend to be more flexible. It's sort of like the shock absorbers in your car. Wind turbine blades can kind of avoid fatigue damage through this new technology. It's not important what the technology is. It's the fact that we saw it demonstrated at conferences, kind of heard rumblings about 6% increase in some of the outputs of a turbine at almost free cost. It sounds too good to be true. It was very close to being true. It was something that we even demonstrated here at the National Wind Technology Center. We had a 101-meter rotor flying up there that we just basically took off the rotor, put on a longer one that had this new technology in it, and it still fit on the same machinery. So in that sense, we had 6% more energy that could be produced by these new machines that fit on our existing machinery that we have. We had to do nothing other than build blades, and we got 6%. It was amazing. And so you see, just like we're talking about here, is this chain of technology being demonstrated at conferences. Was it risky? Maybe a little bit. That was probably as risky as we get. We try something new, demonstrate it computationally, and go and try it. And so it's a good example of something that really was new technology that kind of hit wind industry.
So what is it exactly? Is it a different material for the blade, or?
No, it's the fact that a straight blade, when you push down like a diving board, it just goes straight down. If I had a diving board that was curved and I stood at the end of it, it would twist. And so that twisting mechanism, kind of flapping back and forth, is like a damping mechanism to a blade.
So it's the same material, it's a new shape for the same material.
Bent it.
That's great. Anyone else want to jump in?
It isn't necessarily brand new technology, but it is something that's developed over the past 15, 20 years. Historically, an oil and gas well would have been delivered with a more or less vertical well. And in a formation like the Codell formation that's only about 40 feet thick, if you're drilling a vertical well through that formation, you have 40 feet of contact with the reservoir. If you turn the wellbore sideways, you can drill a well a mile and a half, 2 miles, and then you have that much more contact with the reservoir. And so a horizontal well might cost maybe 5 times as much, but might yield 10 times as much as a traditional vertical well could recover. So that is something that has put American oil and gas companies back in the game when you're competing against other countries or other areas of the world that have conventional reservoirs that are just much easier and less costly to develop.
Great. Joe?
I want to kind of relate what I'm going to talk about to an element of risk. When we first started out, we were using a product made by BASF in Germany. Those of you that have worked with a large organization, they could decide to drop a product line that they've got $50 million of development in Monday morning, and you wouldn't even see it in the bank account. So that was always a big concern of mine. Availability of the scope of the product that I needed, and B, dependent upon them, which did not seem to be a major product in their product line. So we spent probably a year and a half looking at a way we could find an encapsulator. And we could not find one, and it was also the most expensive part of the process of making a PCM. So then I read some research on another process that basically takes the liquid wax, which is what it is, paraffin wax or plant-based wax, and sucks it up into the pores of a porous material. So we started working with it in parallel with making a product with the encapsulated. We have now reached the point where we can take the raw PCM, which is almost a commodity. I mean, you can buy it from any place in the world almost. And we're using that in our end product, which has the flexibility that we're looking for using it. The interesting thing is the raw material cost that we are starting with, which is approximately about 72% of our end product cost. We're dropping that cost by 50%. And at the same time, we're increasing the storage capacity, thermal storage capacity, by somewhere between 30 and 40%. Now, so it was a need to decrease risk and decrease cost and broaden our end market without changing where we were ending up with at the end product significantly. So it's that kind of thing. And the other innovation that we did was, I think I mentioned it, but putting in a sensor in our material that will interact with a building control system. You lose about 30% of the efficiency in a year in this material in a building, depending on being dependent upon the passive fluctuation in temperatures. So if we can know that it didn't charge itself in the middle of the night, and we can run the air conditioning system at the lower rate and reduce energy use in the peak demand period during the day, we pick up 30% more usage during the year and a higher ROI on the installation. So
Yeah, that's great, because it's the same product, but your innovations have made the same product cheaper, better, and more valuable to customers. Yeah.
Yes.
Excellent. Trevor?
So most of the innovation occurs at the portfolio company level, right? Like I said, electric school buses and garbage trucks, and diagnosing diseases before it's too late, and providing financing for commercial solar projects and things like that. So that's where most of the innovation is occurring. I mean, one thing that I think is, at least over the last couple of years, has been innovative is we invest in clean tech. I mean, the Sandhill Row VCs, a lot of VCs lost so much money on Fisker and solar panel manufacturers, their LPs won't let them invest in clean tech. And so we've been pretty bullish on clean tech because, you had two things happening. One, there was a lack of capital. Two, the entrepreneurs that are still in the game have become very capital efficient and are kind of the cream of the crop a lot of times. So I think that was somewhat innovative. Biotech is similar to some extent in med tech. And then one thing that we're doing with this new venture fund that we're going to run in parallel with SCG is we just hired a woman who is the director of corporate partnerships for a few highly regarded Bay Area incubators. and to do things like, let's partner with Siemens and, have these proof of concept pilots be part of our program. I'm just picking on Siemens because he's there. And if you want to do a deal, we can do it.
I'll just take a commission on the.
Yeah, just things like that. We're always trying to find ways to provide value beyond financial capital for our portfolio companies. So what can we do? What kind of programs, or who can we hire, or what connections can we make that do that?
So not so much a cool widget, but you're innovating the VC investment process. And
Yeah, I mean, I like to think so.
Yeah.
We'll see.
Our
It's not all
industry's
web-based
opposite.
yet. but-
Robert, go ahead.
Yes, excuse me, Trevor. I just wanted to comment because we had received some questions before the panel, and I thought they were fascinating because I had this feeling that our industry is the exact opposite of all the other industries represented here, because all your R&D, all your research, all your innovation is really kind of being done by the mid-sized to larger oil and gas companies that have the budget for research and development and things like that. It gets exported to smaller companies if an individual who has worked for an Anadarko for 20 years becomes a master and expert in reservoir engineering or geology or whatever, takes that and forms his
interesting.
own company and brings along with him or her colleagues and stuff. That's how the technology moves more often or not in our industry. And then the most efficient way to get
Interesting.
technology to move in the industry is go through the service companies, because we employ the same completion companies at Anadarko that Noble uses, or Encana, or the other companies. And the pipeline and the conversation is just very, very fluid through the service company route. So, and they do a lot of research and innovation there as
Right.
well.
So instead of little companies aggregating up to the big company, either getting bought or growing into that, it's spinning off the other
Yeah.
way. Little guys coming out and creating new little companies.
Yeah, and you typically wouldn't necessarily, a mid-sized company like an Anadarko wouldn't necessarily buy a small company for its technology, because they typically wouldn't necessarily have technology that you'd want to buy. You might be interested in their assets, and to the extent that you could operate them more efficiently
Right.
and get more from them than they can, that would be a reason why you would want to acquire a smaller firm. So.
Okay. Barbara, you want to talk about NREL and transmission?
I can tell you that when I started here a couple years ago, I mean, it was like walking into a popular science magazine, right? I mean, brown bag lunches galore at demonstrating really cool technology. So I can't even begin to tell you of all the innovations that have come out of NREL. But speaking from my own personal experience, which I talked to in the beginning, there's so many examples, but sometimes it's the little things, and I'll use Jake Aho's example on Siemens. There's something called active power control on wind turbines that let turbines, which are, this variable technology, sort of become good citizens to the grid and provide something like frequency regulation back to the grid instead of relying on thermal units to compensate for variable and uncertain generations such as solar and wind. Well, the physical capability of these power electronics is, in effect, firmware or software to be installed in turbines has been around for a while, but there hasn't been an ask for it. There hasn't been a market, and that's because typically what would pay for that, the revenue stream associated with something like that, would come from an ancillary service market, and these markets are not developed enough out there in the independent system operators, the grids of the U.S. to justify that investment. So we're out there interfacing with stakeholders. In other words, doing education and outreach to the Federal Energy Regulatory Commission or the North American Electric Reliability Council, or all of the grids, to say, hey, the physical capability exists, and if you provide for that either through requirements, i.e. a stick, or through revenue, i.e. a carrot, then you would develop this this world where we can have a much larger penetration of renewable energy.
Well, thanks. It's 5 past, so I'm gonna cut us off. I'd like a round of applause for our great panelists.